Now the purpose of this tutorial is to show you how to differentiate natural log functions, and I've given you 3 examples here of the type of thing that this tutorial will cover. But before we start, I've got to take you back to something called the chain rule. So what is the chain rule? If we have dy by dx, it's exactly the same as me writing dy by d something, let's say t, as long as I multiply by whatever I write here, so in this case it was dt, by dx. It's as if these dt's cancel and we get dy dx. So this is called the chain rule, and going to use that then to differentiate natural log functions. You may remember that if we had y equals the natural log of, say, x, dy by dx is a standard result. It turns out to be 1 over x. If I had, for instance, y equals the natural log of, say, t, this time it wouldn't be dy dx, it would be dy by dt that would equal 1 over t. But what happens if we have not just a single letter here like the x and the t, but something that was more involved? Let's suppose we had y equals the natural log of, say, 3x squared minus 1. How would I cope with differentiating this? Well, what we need to do is turn to the chain rule then up here. We need to have this as a single letter, like I had here, x or t, not several terms like 3x squared minus 1. And so what I do is I let this value 3x squared minus 1 be the t here. So therefore I would have y equals the natural log of just simply t. And I can find dy by dx by doing dy by dt. So look, dy dx would equal dy by dt first of all, and if y equals the natural log of t, dy by dt would equal 1 over t. So that would be 1 over 3x squared minus 1. Remember, t was the 3x squared minus 1. And then according to the chain rule, I've got to multiply dy by dt by dt dx. I need to differentiate what I called t by x. So t was 3x squared minus 1 in this example, so timesing it by the differential of 3x squared minus 1 with respect to x gives me just simply 6x. And putting this together, 1 times 6x is 6x, and it's all over 3x squared minus 1. Let's try another one. Okay, let's try y equals, and we'll have the natural log of, say, 4x cubed minus 2x squared plus 1. You'll notice that this is not a single letter like we had up here, x or t. So to get around this differentiation, we call upon the chain rule, and that is dy by dx equals dy by dt times dt dx. Now, I'm going to let this value in the brackets, 4x cubed minus 2x squared plus 1, be the t. So I have y equals natural log of t. And so dy by dt is 1 over t. So that's going to be 1 over 4x cubed minus 2x squared plus 1. Put that in brackets. So that's the dy by dt part of the chain rule done. And now I have to multiply it by dt dx. So all I need to do is take my t value, which was 4x cubed minus 2x squared plus 1, and differentiate it with respect to x. In other words, that will give me dt dx. And if I do that, differentiating 4x cubed is 12x squared. Differentiating minus 2x squared with respect to x is minus 4x. And 1 disappears. So therefore, what I have when this is multiplied together is simply 12x squared minus 4x all over 4x cubed minus 2x squared plus 1. Okay, and I could try this with many other types of examples. Let's try a trigonometric one, for instance. Okay, so we'll just take these ones off. So suppose we had the natural log of sine x. Then dy dx would equal, I nominate the sine x to be my single value, in this case t, so I have y equals the natural log of t, and in the chain rule I have to differentiate y with respect to t, dy dt. dy dt is 1 over t, and if t was the sine x, it must be 1 over sine x. Put that in brackets. Now I need to multiply by dt dx. In other words, I need to differentiate t with respect to x, and t was sine x. So differentiating sine x with respect to x is cos x. Simplify this by multiplying the two fractions together. 1 over sine x times cos x gives cos x over sine x. And some of you might recognize this as being cot x. But I'll just leave this as cos x over sine x for this example though. What happens also if I have a number in front of my function? That number stays put. I'll show you. Let's suppose we had y equals, for instance, 3 times the natural log of, say, 5x plus 3. Then what I do is to find dy by dx, I nominate 5x plus 3 to be the single letter t. So I have 3 times the differential of the natural log of t, which is going to be 1 over t. In other words, 1 over 5x plus 3. I'll put that in brackets. So that is dy by dt, and I have to multiply it by dt by dx. I have to multiply it then by the differential of 5x plus 3 with respect to x. Differentiating 5x is 5, and differentiating the 3 disappears. So at the end of the day, what have we got? We got 3 times 1 times 5, which is 15, all over 5x plus 3. And so hopefully you can use these examples to help you differentiate then the natural log of any function that is not a single letter, like x or t. Now in general then, if we have y equals the natural log of some function of x, by applying the chain rule we can differentiate this and it becomes 1 over f of x, and then we multiplied this by the differential of f of x, which we'll call f dash of x. And if we put this together, we find that dy by dx equals f dash x over f of x. And this is a result that you ought to learn. It's something that we're going to come back to later on in integration.